Hello friends, our today's topic is Poisson distribution. Definition: a random variable x follows Poisson distribution if it assumes only non-negative values and its probability mass function with parameter m is given by probability of capital X equal to small x is equal to e raised to minus m raised to x upon x factorial, where values of x are 0, 1, 2 up to infinity, and parameter m is greater than 0, and this is equal to 0 otherwise. Note: Poisson distribution, it is limiting case of binomial distribution with parameter n and p, where m is equal to np. Properties of Poisson distribution. First property, mean means expected value of x, m. Second property, variance is again m. Third property, standard deviation is square root of variance, means square root of m. Fourth property, if m is not an integer, then mode of Poisson distribution is integer between m minus 1 and m, and if m is integer, then there are two modes at x equal to m minus 1 and at x equal to m. So these are properties of Poisson distribution. Then we see some examples of Poisson distribution. If x is a random variable following Poisson distribution with relation probability of 4 into probability of x equal to 0 is equal to probability of x equal to 1, obtain p of x equal to 3 and given e raised to minus 4 is 0.0183. Here given 4 into probability of x equal to 0 is equal to probability of x equal to 1. Formula of Poisson distribution is e raised to minus m raised to x upon x factorial. We use this for probability of x equal to 0. Then here also e raised to minus m raised to x upon x factorial. Here we replace x by 0 and here we replace x by 1. Then we get 4 in bracket e raised to minus m raised to x is 0 upon 0 factorial. Here x is 0 and here x is 1 e raised to minus m raised to 1 upon 1 factorial. 4 into e raised to minus m raised to 0 is 1, 0 factorial is also 1. This is equal to e raised to minus m into m. This e raised to minus m is cancelled with this e raised to minus m. Therefore, value of m is 4. Probability of x equal to 3. This is equal to our formula is e raised to minus m raised to x upon x factorial. E raised to minus m is given 0.0183 into m is 4 raised to x is given 3 upon 3 factorial. This is equal to 0.0183 into 4 raised to 3. 4 raised to 3 is 64 upon 3 factorial. 3 factorial means 3 into 2 into 1. And if we calculate this, we get 0.1952. Therefore, probability of x equal to 3 is 0.1952. Then we take one more problem. For a Poisson distribution, the ratio of probabilities of x equal to 0 and x equal to 1 is 1:7. Find probability of x equal to 3. Given e raised to minus 7 is equal to 0.0009. Given ratio probability of x equal to 0 and probability of x equal to 1 is 1:7 means 1 upon 7. E raised to minus m raised to x upon x factorial. This is for x equal to 0 upon e raised to minus m raised to x upon x factorial for x equal to 1 is 1 upon 7. This is given. Put x equal to 0 here, put x equal to 1 here, we get e raised to minus m into m raised to 0 upon 0 factorial upon e raised to minus m raised to 1 upon 1 factorial for x equal to 1 is equal to 1 upon 7. This is equal to e raised to minus m raised to 0. Anything raised to 0 is 1 and 0 factorial is again 1. So here e raised to minus m upon e raised to minus m into m is 1 upon 7. Here we cancel this e raised to minus m with this e raised to minus m. We get 1 upon m is 1 upon 7, or we can write this as m is 7. Here value of m is 7. Then probability of x equal to 3 is equal to e raised to minus m raised to x upon x factorial. This is equal to e raised to minus m means e raised to minus 7 raised to x is 3 from 3 factorial. E raised to minus 7 is given 0.0009. This is equal to 0.0009 into 7 raised to 3. 7 raised to 3 is 343 upon 3 factorial. 3 factorial is 3 into 2 into 1 means 6. This is equal to 0.3087 upon 6. Answer 0.5145. Therefore, probability of x equal to 3 is 0.05145. This is our final answer. A variate x follows Poisson distribution with parameter 3. Evaluate probability of x equal to 1, probability of x less than 1, probability of x greater than 1 given a raised to minus 3 is equal to 0.0498. Solution. Here value of m is given 3. First, probability of x equal to 1 is e raised to minus m raised to x upon x factorial. This is for x equal to 1. E raised to minus m is 3 into m raised to x means 3 raised to 1 upon x factorial. X is 1 means 1 factorial. This is equal to a raised to minus 3 0.0498 into 3 upon 1, and this is equal to 0.1494. Means probability of x equal to 1 is 0.1494. Second, probability of x less than 1. This is equal to probability of x is equal to 0, and its formula e raised to minus 3, value of m is 3 into 3 raised to x is 0.0 factorial. This is equal to e raised to minus 3 0.0498 into 3 raised to 0 is 1 upon 0 factorial is again 1. So finally our answer is 0.0498. Means probability of x less than 1 is 0.0498. Then third condition, probability of x greater than 1. This is equal to probability of x equal to 2 plus probability of x equal to 3 plus up to infinity 1 minus probability of x equal to 0 plus probability of x equal to 1. We have already calculated probability of x equal to 0 is 0.0498 and probability of x equal to 1 is 0.1494. If we add these two quantities, we get 0.1992 and final answer is 0.8008. Therefore probability of x greater than 1 is 0.8008. Then we take next example. The average number of phone calls per minute in a call center is 4. Find the probability that during a specific minute the number of calls is only 2. Given e raised to minus 4 is 0.0183. Solution. Here average means m is given 4 and we have to find probability of x equal to 2. Its formula is e raised to minus m raised to x upon x factorial. Here value of m is 4, so e raised to minus 4 raised to x upon x factorial. Here e raised to minus 4 is 0.0183, therefore 0.0183 into 4 square is 16 upon 2. This is equal to 0.2928 upon 2 is equal to 0.1464. Therefore probability of x equal to 2 is 0.1464. Then we take next problem. It is observed that 1% typing error is committed by a typist. Find the probability that in 100 pages number of typing error is only 1 and less than 2. Here 1% typing error is committed by a typist, therefore P is equal to 1 upon 100 and this is equal to 0.01 and value of n is 100. We know that m is nothing but n into p, n is 100 and p is 0.01 means m is 1. Then first case, probability of x equal to 1, number of typing errors is only 1, the probability of x equal to 1 is equal to e raised to minus m raised to x upon x factorial. This is for x equal to 1. This is equal to e raised to minus m is 1 into 1 raised to x is again 1. This is equal to e raised to minus 1 is 0.3679. Probability of x equal to 1 is 0.3679. Then second, probability of x strictly less than 2. This is equal to probability of x equal to 0 plus probability of x equal to 1. Probability of x equal to 0 is e raised to minus m is 1 into m raised to x is 0 upon x factorial plus we have already calculated probability of x equal to 1 which is 0.3679. We use this value here. This is equal to e raised to minus 1. E raised to minus 1 is 0.3679 plus 0.3679. This is equal to 0.7358. Therefore, probability of x less than 2 is 0.7358. This is final answer.